So let's try some other examples here of this. So here's one. Let's try this. This call it our first example. We need to find the tail area. So you've seen the written example. So I'll give you this as a chance to work on it, and then you come back and watch this video. Okay. So we got to find the tail area. Then we double it, and then do 1 minus that answer, and that should be the middle area. Okay, that's what we're looking for here. So going to stop the video if you want. If you think you want to try it, stop the video, try it, and then come back and watch us. Okay. So what I see here is because this probability is bigger than a half, that tells me that the z-score has to be positive. And since it's let's see, how do I do a highlighter here? I don't know. Let's see. Yeah, there it works. So we know that yellow area that I'm shading in is equal to 0.55. So that tells me it's a positive z-score. So to find this area here, let's get fancy and do green and highlighter. So that's the tail area we want to find. So that area is going to be 1 minus 0.55, so that's 0.45. Okay, so because the tail area has got to be the same because it's symmetric, so to find that area between them, whatever z-score that is, we know that this is 0.45. And the negative of it, the opposite sign, will also have a tail area of 0.45. So 0.45 plus 0.45 is 0.9. And then to find that middle area, 1 minus 0.9, well, that tells us only 10% or 0.1. The probability of falling in between those two z-scores, whatever they are, is only 0.1. Okay. So hopefully that's what you found. Now, over here, I'm just thinking maybe I want to change this, not use 0.45 because it's going to be the exact same area, right? Well, let's talk about why that's the exact same area. So I know if the probability is only 0.5, that some z-score, right? I know when the z-score is 0, 50% of the distribution is to the left of it. Well, this is not 50%, that's less than 50%. So that tells me that the z-score is going to be negative. Whatever that z-score is, I know it's negative. So that's going to be 0.45. So that tells me the positive of it will be here, and that'll be 0.45. So you see how it's the exact same question. Here, we don't have to do any subtraction here. So that works that way. So what if we try a different number? What if we try the probability? I don't know, let's make it, how about 0.25? That way it's a quartile. That might work better. Why don't you go ahead and try that one, and then come on back and watch, and I'll for me, I'll keep setting it up, but you can come back and watch it if you lost. Okay. So again, I see that probability is less than 0.5. So that tells me this z-score is going to be down here. It's going to be some negative number. And since that's always to the left, that's going to be 0.25. And if we're looking for in between, we know to the right, the positive of that, because right, if it's a negative z-score, it's just going to turn it positive. And that's also 0.25. So that tells me 50% is in the middle. And that's exactly what we're looking for here, because it's the quartiles. Okay. Let's see. Okay, then the next question you had, now I figured I'd just record that instead of giving you, I mean, it's in the textbook, and you can go look at, actually, you can go look at page 100, number 4 is exactly the same kind of question. So why don't I do that? All right, so page 100, number 4 says, well, here, I got my textbook open right here. Let me go find it. Problem set, page 100, number 4. Here we go. So this one you don't have the answers to, but well, you get A. So you go look that one up in that file or in the textbook. So we want to, what's z-score constitutes the middle 95%. So let's think about what we just did here. Before they were telling us the tail area, now they're telling us the middle area. So if we've got 95% of the distribution is between these two z-scores, one thing I know they're the same number, just one of them is positive and negative because of symmetry. Now, if we want to find those tail areas, and this is how to do it by hand with a table, we're going to do 100 or 1 minus 0.95, and that's going to be 0.05. But now that's both areas, right? That's both this area here in this area here. But in the z-score table, I want one of them. And since the z-score table always tells us to the left, we're going to take that 0.05 divided by 2. And that tells me this lower tail area is 2.5% or 0.25. So we got to go to that normal curve table. And let's see. We got to find it left area 0.025, or at least as close as we can. 0.02708. Let's see, it's going to go this way. There we go. Exactly. How about that? That never happens. So the z-score is negative 1.96. So this z-score here is negative 1.96. And since because of symmetry, this is going to be positive 1.96. Now, don't take my word for the symmetric part. If I'm looking for the z-score that has, here, let me change my ink. What if I'm looking for the z-score that has all that area to the left of it, all that probability to the left of that? Isn't that 0.27 or 0.02025 plus the middle 0.95, which is 0.975? We can go look in the table for that. 0.97 should be a nice number because the left-hand side was what I'm looking, 0.9750 right there. See, it's positive 1.96. See, that's how I remember. That's how you read it. You go 1.9, then your second decimal place there is 6. See how that works? So that confirmed. Much easier, just remember symmetry, okay? So that's one way to do it. And now let's go back and take a look at that other question. And I'm definitely going to send you to how do I clear my writing? I'm going to send you that David Lane applet. If you haven't been there, I'm going to take another stab at getting you to do it. The middle 99%, well, if we were going to do that by hand, the middle 99%, well, if there's 0.99 in the middle and 1 minus 0.99 is 0.01, and half of that will be the tail area. That's 0.005, right? And that's going to be 0.005 tail area. So now we'll go to our z-score table and see how close we can get. Sometimes you got to go in between. For these nice ones, usually it usually is a nice 0.20s I need. Right here. See how it's in between? See that star? That means it's exactly halfway between it. That doesn't happen often, but negative 2.5 and halfway between 0708 is, so that would be 2.575, and of course it'll be negative on this side and positive on this side. And symmetry, you could go look up 0.995 and you'd see it would be positive 2.5. There'd be a star on the other side. Okay. The other thing before I leave this normal curve table, and this is going to save you some time during week 8. Week 8 when we do that. See, these are a little mini table that Dr. Stevens has pulled out of the regular normal curve table, and we're going to use for confidence intervals. What that means, we'll talk about later. But just see how it's 90%, 95%, and 99%. Those are common values that we use all the time. Okay, so now how about shortcuts? What if we have, because if you've done the MyOpen math questions, they give you some weird ones. So not nice, neat ones. I mean, you can do it the same way. Find the tail area, double it. It's not impossibly hard. But tech is wonderful. It's not photo math. I wish we didn't have photo math, but Still, it's a cool app. I don't think Photomath does the statistics. So let's see. I want to do, yeah, if you go to, oh, here we go. Here, let me clear this out. I want to make sure you see how to find these calculators. No, I don't want to pause you recording. I want to clear all my writing. Here you go. If you go to modules, come on, load. There, and you go to course resources, the course resource module, you see that online statistical tools. If you click there, here's all those binomial probability applets that we used last week, and here's a normal CDF. This is normal. It's a normal curve, a cumulative probability distribution. I don't quite remember what the DF stands for, but it's a cumulative frequency. And here's a normal curve table. And if we were looking for what z-scores cut off the middle 90, what was it, 95%, we want to do an area from it. No, we got an area. We know the area is a probability, and we know that it was 95%, wasn't it? Standard normal curve, and we want to go between, and you see where they're getting the negative, and it gives you the nice shaded area. We don't have to do that for us. It doesn't give us the tail areas, but that's something you could figure out. You don't really need the tail areas because we know the middle. We want the middle. We get the middle area. We want to find the z-score that cuts off the middle areas. Here, I ought to do a pointer here so you're not just looking at my mouse. So I had to select value from an area. So I'm looking for an X number here. Okay. And that's how that works. Now, what if I had asked you about the potatoes, like Bob's potatoes? I'm looking at page 100 again here. Let me come back and look at the book. Page 100 in Bob's potatoes. Now, yes, you got Dr. Stevens' answers in the back, but let's talk about David Lane. I think I've got another video that I've linked to. What weights delineate the middle 90% of Carl's potatoes? Well, to do this by hand, you gotta come up with a z-score. I know you gotta figure out what z-score cuts off the middle 90%. Do I want to do this by hand? I'll do it by hand. And then we'll talk about the calculator. I don't want you to have to do this by hand, folks. I mean, you're never going to do these calculations again, but you'll have to interpret the results, and that's the more important part. So here's my lame normal curve. I want to know what z-score cuts off the middle 90%, because I want to know what weights are. Now, right now, I'm still on that standard normal curve because I'm just dealing with z-scores right now. That means the mean 0, the standard deviation is 1, right? The mean in the middle. And we want to know what z-score cuts that off. Well, if we go back and look at that little normal curve table, come on. And we certainly we could find the tail area and well, what is the tail area? So 1 is becoming more than I wanted to do, but that's okay. 1 minus 0.9 is 0.1. Half of that is 0.05. So 0.05 here, 0.05 here is the tail area. We're going to look in the middle of the table and find, let's see, what is it? 1.645. Yeah, right here. So that'll be 1.6, halfway between 4 or 5. So that z-score is negative 1.645 and positive 1.645. We could have also just saved ourselves a little bit of time and looked at that to see how that the middle 90% is one of these nice common ones, 1.645. Then to do it by hand, now we got to find out the weights. We got to convert this back to weights. So let's go back and look at the problem set. We know that the mean is 8 and the standard deviation is 1.2. So we know the z-score for the lower cutoff is 1.645. That's equal to some potato weight minus the mean of 8 divided by the standard deviation of 1.2. So the algebra is to multiply negative 1.645 times 1.2 to clear that fraction. And then we have to undo the subtraction of 8 by adding 8. We want to get some number, whatever that number is, and that's the bottom cutoff, the bottom weight. And to do the upper cutoff, you'll just, instead of negative 1.645, you'll write positive 1.645 equals some number minus the mean divided by 1.2, and same algebra, right? Multiply by 1.2 and then add 8. That's x, all right? And that works. It's not hard to do. If we want to use David Lane, though, here, let me leave these numbers up here. I went to David Lane because we want values. No, we know areas. We know areas. We know the areas and middle area is 90%. So I'm going to change this to 0.90 or 0.9. We got to change it because it's not the standard normal curve now. It's a mean of 8 and a standard deviation of 1. And we want to find the between, and that's what the answer is to this part, and that's what the answer is to this part. Okay, so much easier with a calculator, and it's just as hard conceptually to do. So I'm perfectly fine. If this were on a quiz, screen capture that result and put it in a quiz, okay? Can't just give me the answer because that won't earn you, unless it's just an answer question. But if it's a show you work, I want to see how you do that. And like I'm going to say this again, use the calculators, okay, folks? Let's see, what else did I want to do with that problem? Is there anything here? I think I answered your question about the middle 99%. Yeah, and I know I've got this video someplace else. I'm probably in my what to do. Let's make sure. Whoops. No, not this page. I want to go back to here. And then yeah, in modules, let's make sure I point this out because I've got people that's asking me how to do some of this stuff, and I don't know if they're seeing this. So I'm going to just do this again, put a plug in it for again. I really hope you're doing each week, folks, is go to modules and Canvas, go to modules. Let me collapse some of these things. I don't realize I had them so many open. Sorry, it's taken up making this video longer than it needs to be. As this is week 7, right? Yeah. See, in the week 7, oh, this is the exam. And this is week 6 right now still. Week overview, I usually have like here's my page with some, about using all the applets and everything. I don't know if you're watching that. So I would recommend you really for the rest of the course, folks, you're going to want to be using calculators. You can do it all by hand. It's not impossible to do it by hand, but it's just so much easier. Okay, so this is a walk through a couple of tech problems from the book. Here's a walkthrough for the whole problem set for this week. Okay, and then of course these 3 videos, if you haven't watched these videos about sampling distributions, you want to do it. I mean, you can probably get through the exams without watching them, but you want to watch them before, you want to watch this guy before we start chapter 7. It'll just make the work so much, it'll help the work make more sense what we're doing. Not too long, what is it? 12, 20, 26 minutes, 11 years ago. He does a nice job, guys, even if it's an 11-year-old video. All right, I'm going to stop this video. It's getting too long. Give me a yell if you need help.